Hello again. We're graphing inverse variation type problems. Y equals 1 over x. I guess you could say a over x minus h plus k, but that's making something more difficult than it has to be. So basically what we're doing is we're graphing inverse variation problems. And this time, well, the last time we added a 2 after the fraction. What we're going to do now is incorporate a addition or subtraction with the actual fraction itself in the denominator. And this is pretty cool. We did a shift in terms of horizontal asymptotes. Now what we're going to do is we're going to do a shift in terms of vertical asymptotes. And I went ahead and I wrote my table, -2, -1, 0, 1, and 2. And that's the table we've been using for everything so far. Well, now the table switches. And the reason why is because I want my undefined value to be in the middle. Well, 1 subtracted 2 is going to be undefined. It's 2. Bam! That's what I'm going to use for my undefined value. And then just go 1 and 1, respectively, on each side, 1 and 1. Add 1, add another 1, subtract another 1. So when I go ahead and I'll do this one first, because that's the one I've always been doing. And I'll do this one in black. When I substitute in -2, I get -0.5. When I substitute in -1, that one's undefined. When I substitute in 1, 1 divided by 1 is 1. 1 divided by 2 is 0.5. Pardon me. And I'm going to go ahead and graph it. No surprises here. Something like this, where the vertical asymptote is at x equals 0. That's the spot it'll never touch on the x-axis. On the x number line. Yeah, it never touches x at 0. Horizontal asymptote is at the equation, I should just say equation actually, y equals 0. You'll never touch at this equation right here. Anything on the x number line, which is actually the equation y equals 0. Domain and range, same thing. -infinity to infinity does not include 0. -infinity to infinity does not include 0. This one changes though. When I substitute in 2, 1 divided by 2 minus 2, pardon me, is undefined. 1 divided by 3 minus 2, you do 3 minus 2 first. 3 subtracted 2 is 1. 1 divided by 1 is 1. When you substitute in a 4, 4 subtract 2 is 2. 1 divided by 2 is 0.5. When you subtract in a 1, 1 subtract 2 is -1. 1 divided by -1 is -1. When you subtract in a 0 subtract 2 is -2. 1 divided by -2 is -0.5. I go ahead and I do that one really quickly. I should probably do that in a different color. I will do that in blue. 1 -1, 2 undefined, 0 -0.5, 3 1, and 4 0.5. Now the asymptote for this one, the vertical asymptote, is at 2. So it won't actually include this aspect of the line. So what happens is, it's basically the same graph, except somebody just picked this one up and just moved it 2 spaces over. So someone's going to take this one and move it 2 spaces over. And that's my graph. And I'm going to signify this little dashed line for its horizontal asymptote for this second equation right here. So, writing down all the info that I need. My vertical asymptote for this one is at x equals 2. Now, it's not coincidental that when I subtract or I add a number that it changes the vertical asymptote. The vertical asymptote is just the opposite of this number divided by the number in front of x. The number in front of x is 1. So the opposite of -2 is 2. 2 divided by 1 is 2. Vertical asymptote 2. Horizontal asymptote, still the same. Y at 0. If I want to figure out my domain and range, respectively, -infinity to infinity, range is -infinity infinity to infinity. The domain does not include 2. And the range does not include 0. So there you go. We're going to try one last lesson with the inverse variation because I think it's really cool. And you can think about aspects of horizontal and vertical asymptotes. And there's actually a different way to figure out vertical and horizontal asymptotes with more complicated equations. I guess you can call them functions, but I guess it depends on the graph itself. But until that time, we'll go ahead and review this very quickly. Have a good day for right now. Goodbye.